Let's talk about improper integrals. And improper integrals are integrals where the value might not exist within an integral, and that could happen, let's say, if you're dividing by 0, or also if you're taking an integral as something approaches infinity. If you write infinity as one of the limits, that's improper. So here's an example of an improper integral where one of the bounds, in this case our upper bound, is going to be infinity. So we're asked to find the area under the function 1 over x cubed from 9 to infinity. So what many people would write is, well, this is just 9 to infinity of 1 over x cubed dx. Well, this is wrong. That's improper. You can't have this infinity in the limits. The way you'd have to write it is, what we're doing is we're taking the limit of this real number a as it approaches infinity. So in a way, this is kind of a really close estimate. And then we can take the integral from 9 to a of 1 over x cubed dx. And from here, it's just simple integration. The only thing you have to worry about is you always got to keep the limit. At no point should you write infinity inside your expression. So limit as a goes to infinity of, well, the antiderivative of 1 over x cubed, that's 1 over negative 2x squared. And we're going to evaluate that from 9 to a. Once again, a, not infinity. If you write infinity, that's wrong, and you're going to get points off. And from there, we can go ahead, write that out. Limit as a approaches infinity of 1 over negative 2a squared minus, well, it's going to be minus a negative, so it's plus 1 over 2 times 9 squared, which equals, and at this point you can take the limit as a approaches infinity and say that, well, this is 1 over pretty much infinity squared, which is 0. So it's going to be 1 over, I'm sorry, yeah. 1 over infinity squared, that's 0, so it's going to be 0 plus 1 over 2 times 9 squared. 2 times 9 squared, 9 squared is 81, 2 times 81 is 162. So that's the area under the function 1 over x cubed, and we did this using proper integrals. We didn't use an improper integral. And just things to remember is to keep writing limit as a approaches infinity as long as you have infinity inside your expression, and never ever write infinity in one of your limits, ever. In the next video, we'll have an example of when the limit, where the integral has a problem in the middle, where both of the limits are fine, but somewhere in the middle we get something that makes our integral improper.